This video is going to go over some of the 7.5 practice for you to give you some examples to work with, but not all of it. So first, the very first question, you see it as a spacer. These are some diagrams and formulas that might be helpful to write down as we go through these. So the first one, in a circle, any segment connecting 2 points on the circle is considered a chord. So in this case here, from this point to this point, that's a chord. But a diameter is also a chord because it connects 2 points on a circle. It just happens to be the longest type of chord you can draw because it goes to the center. A radius is not a chord because it starts at the center of the circle, which isn't actually on the circle. But we know a radius is half the diameter, so that's an important segment in a circle anyway. So knowing what a chord is will help you with some of these problems. Also, there are certain angles in a circle that we have to be familiar with as well. So in a circle, in the sector and arc length formulas, we were dealing with what's called central angles. So a central angle is an angle that is at the center of the circle. That's always going to be whatever measure, it's going to be the same degree as whatever the arc is. But if you bring that angle all the way back to the very edge of the circle, you have what's called an inscribed angle. So an inscribed angle is going to go from, it's going to basically be where two chords meet at a same point and they open up to whatever that arc is. This angle here is considered inscribed. Inscribed is drawn on the circle. So an inscribed angle in a circle is formed by two chords that have a common endpoint. So in this case, B would be your endpoint. Now there's a really cool property, well, easy property for inscribed angles, and that is it's always going to be half the measure of the central angle. So if you have a central angle, you know, for instance, let's say this angle here is maybe 130 degrees, then this angle would be half of that. So angle ABC would be 1/2 of 130. And so that would be 65 degrees. And if this were 50 degrees, this would be 100. So that relationship is always going to be true between an inscribed and a central angle. And of course, we know that all the arc measures add to 360. So this formula here is going to be important for our work today. The measure of the inscribed angle is always half of the measure of the central angle that opens up to the same arc. Let's do a couple examples. We'll do number one together. I will do A, you can try B. So A, in circle P, the central angle, angle BPA, is 104 degrees. What's the value of X? Well, X is the angle that's on the circle. This is the inscribed. So we know that that angle is going to be half of that central angle that opens up to that same arc AB. So I know that X is 1/2 of 104. Or you could say 104 divided by 2. So if you need to use a calculator, that's fine. That would be 52 degrees. So we're going to put 52 in there. Try letter B. Try on your own. Pause the video, see if you can do it. Okay, hopefully you've gotten to figure out that the angle that is half the angle is provided for us. So we know that 43 is going to be half of angle X. We don't know angle X, but what I can do is I can multiply both sides by 2. So that if I times 43 by 2 and times 2 by that 2 will cancel out the 1/2. So you're doubling the 43. And so that's going to give you 86. So 86 degrees is the measure of X. So this should be twice as much as that. So we're basically either dividing by 2 or multiplying by 2, depending on which one we're given. All right, question 2. In circle A, the measure of arc WX is 120 degrees, and the measure of arc YX is 156 degrees. And what's the measure of angle WXY? So let's first see what we have. So arc WX is 120. Arc YX is 156. But the arc that we need to know to be able to get this problem is arc WY. So I know that all 3 of these arcs add to 360. So I know 120 plus 156 plus arc WY. That sum is 360. So one thing I can do is I can add these together. And that's going to give me 276. And if I take that number away from 360, I'll have the leftover amount. So let's put that in the calculator. So that arc degree is 84 degrees. So 84 is the arc. Now the question wants to know, what is angle WXY? So let's carefully trace that out. WXY, I'll keep it in red, is starting at W, going through X, and then going over to Y. It's not in the center, it's the inscribed angle. So we have to first realize that this central angle here at A, that's going to be 84 degrees. That's the same as the arc, because that opens up to the arc. So the inscribed angle WXY, we say the measure of angle WXY is going to be 1/2 of this 84 degrees. So 84 divided by 2. And that's going to be 42 degrees. So WXY is 42. So now I have the inscribed angle, the central angle, the arc, both of those open to, in addition to the arcs that were given to us. Now write all this down because I'm about to erase it and have you try letter B. So I want you to try B. Here, I'll write this first in case you're not listening but watching. Try on your own. Pause the video. Okay, hopefully you've gotten a chance to try this. So let's see if we can recall what we did in the previous problem. So in circle O, the measure of angle BAC is what we're trying to find. That's this angle here. And so it's very similar to the last problem. We need to know X. Now it's not asking for X. Okay, BAC is here. X shouldn't be there, right? Our X, the value we're trying to find is over here at angle A. So trust this right here. So these 3 arcs add to 360. So first I'm going to look at arc BC. Arc BC plus the 125 plus the 137, that sum should equal 360. So add these 2 together first. Let's put that in the calculator. So that's 262. And then we're going to subtract that from 360. So arc BC should be 98 degrees. So 262, and then subtract from 360, you get 98. All right, so now that I know that's 98 degrees, I know that the central angle is 98 degrees, but the question wants to know the inscribed angle. So remember, inscribed is always going to be the angle that's drawn on the circle pulled all the way across, and that's half the central angle. So we're going to do the measure of angle BAC. I'm not sure why that says WXY, but it should say the measure of angle BAC. I'll fix that when I actually make the assignment public. Is going to be 98 divided by 2, 1/2 of 98. Well, half of 100 is 50, so half of 98 should be 49. So that should be a 49-degree angle, 49 degrees. Awesome. Let's do a couple more. All right, just a couple more questions to solidify this concept. Question 3, in circle O, the measure of angle AOB is 86 degrees. Let's write that down. The measure of angle AOB is 86 degrees. What is the measure of angle X? Well, this one's different, right? Because it's not in the same direction, right? It's off to the side. But what I want you to understand is as long as they open up to the same arc, so we have 86 degrees here, as long as the endpoints of those chords open up to that same arc, it doesn't matter where it goes, right? It could go over to the side. That degree is the same as that degree. Is the same as that. All three of those are the same. You can make an infinite amount of those. And each of these angles, as long as it's on the circle and opening up to the same arc on the opposite side of the circle, it's going to be the same measure. So I know that this angle here in the same direction of that 86 is going to be half of the 86. So that'll be 43 degrees. So it doesn't matter if the angle's over here or over here, they're all going to be 43. So that's a 43-degree angle since that one's 86. Question letter B is going to be very similar. Try this on your own. So we're given APB, that's 122 degrees, and we want to know angle X. And it's going to be kind of the same type of problem. You're going to do 1/2 of that 122 degrees. So when you read an angle, you always start at the letter. So A, you go to the middle letter is the vertex. The vertex is the point, where the two sides of the angle come together. And then it goes to the other side of that. So APB, the angle itself is where the vertex is. So that P is where the 122 is. So this would be angle ACB or BCA, as long as the C is in the middle. Anyway, half of 120 is 60, so half of 122 should be 61. Okay, question 4. This will be the last one on this video going over this concept. If an inscribed angle intercepts an arc whose measure is greater than 180. So imagine this picture here. You have an inscribed angle. It's opening up to an arc bigger than half the circle. Think about this. Half the circle right here would be right here. So that would be like if that's a diameter, this would be 180 degrees here, right? So if that arc is bigger than 180, what kind of an angle does that make? We have 3 choices. We have acute, right, or obtuse. If you need to look those up, that's fine. But an acute angle is always going to be less than 90. An acute angle looks something like this, where that degree is less than a right angle. There's a right angle that is equal to 90 degrees. And so that might look like a nice 90-degree corner. And then there's obtuse, which is greater than 90. So that would look like maybe like that. So out of those angle choices, this angle right here is actually greater than 90 because this would be like a 90-degree angle there. So since this is a little bit more, that's going to be obtuse. It's going to be obtuse. Now, if it opens up to 180 degrees, I want you to think about taking 180. You know, this is an inscribed angle, right? So 180 divided by 2, or 1/2 of 180, is exactly 90 degrees, right? No matter where you put that 90 degrees or that angle, it's going to be a right angle. If you take a number bigger than 180, say 200, 200 divided by 2, well, that's going to be 100. That's bigger than 90, so that's obtuse. So you can think of, just plug a number in there that represents a number greater than 180, and you'll see that if you cut that in half, you get an obtuse angle. This is going to always be a right angle, so this would be right. And so that should lead you to believe that if you have an arc that's less than 180, take a number like 60. Take 60. That's less than 180. Or sorry, take a number less than 180, like you don't have to go that low, 60. It could even be, 150. If I take half of that, that's 75. 75 is less than 90, right? So that's going to be acute. So this is going to be right. This is going to be acute, since that's less than 90. So obtuse, right, and acute. Okay, that's it for this video. The next video will cover the next topic.